Today we're going to keep going with section 1-2. We're going to talk about more things you can do with a set of numbers. Specifically, we're going to talk about standard deviation and linear transformations. So let's just start with the list of numbers. Let's say you have a summer lawn mowing business and you have 5 lawns. And these are the prices you charge, based on the size of the yards. You charge 2 people 25, a 30, a 35, and a 50. So let's just start with finding some info out about this list of numbers. All right, if we're going to add these numbers together and divide to find the mean, remember mean is x with a bar over top of it. If I add those up, it looks like I'm going to get 165, and then I'm going to divide that by 5, and I have a $33 average. Okay, mean is obviously an important number. Your grades are means, for example. Another very important number is the standard deviation. We're going to call that little s. You can call it little s with a little x on it. That's what your calculator calls it. And standard deviation is a measurement of how spread out these numbers are. Loosely interpreted, it is the average distance from the mean. The mean is 33, so on average, how far away are these numbers from the mean? It's not exactly that, and there's some kind of complicated reasons why, but let me just show you how to find it, and you can generally think of it as distance from the mean. Okay, so first thing I want to do is just list my values. All right, list these in your notes, just so you'll have this down once. We won't do this every time, but this helps us understand what's going on. Okay, those are my x values. Those are my my lawn mowing prices. My average, remember, is 33. So the first step in finding a standard deviation is going to be finding the average. Okay, the next step is going to be to find the deviations. And a number's deviation is its distance from the mean. So how far away is each item from the mean? And you're going to find that, and this could be a plus or a minus value. You're going to do each number minus the mean. So I'm going to call this column x minus x bar. So I'm going to do 25 minus 33. This is 8 below, and this is 8 below, and this is 3 below. We are 5 above and 17 above. Deviations should always add up to 0. All right, if you really use the mean, you subtract, these numbers are all going to sum up to 0. Those are called the deviations. Now, some of these, we kind of want to average these numbers in a sense, but you can't average these numbers because they add up to 0, because we haven't taken absolute values, basically. So I'll tell you my thoughts on how we should find standard deviation someday when I feel like ranting, but right now, what we're going to do is we're going to square these. We're going to find the squared deviations. So I'm going to square -8 and get 64, and 64, and 9, and 25. And I've got to remember what 17 squared is. That's 289. And I have my squared deviations. Okay, now those I want to sort of take the mean up. All right, I've got them to be all positive, but I'm now squared from where I was, so we're going to have to get rid of that in just a minute. But here's what we're going to do. We're going to add these up, and then see what's next. Okay, after my short calculator break, these numbers add up to 451. This is the sum of the squared deviations. All right, now, we're sort of going to average those, but instead of taking 451 and dividing it by 5, I'm going to divide by 1 less than my number of numbers. All right, this has to do with something called degrees of freedom, and we will talk a lot about those in second semester. And this is the part that makes it not really the average distance from the middle. All right, we're going to divide by 1 less than the number of numbers. So I'm going to do 451 divided by 4, and that's 112.75. So this is what's called the variance. Okay, standard deviation, it's called S. We're getting ready to square root it in a minute to get that. Before you square root it, it's s squared, which is called the variance. From time to time, we'll use variance. It is the cousin of standard deviation that you don't use that much, but on the way to finding standard deviation, you stop here at the variance. Okay. This is going to be the standard deviation. Once you square root this number, we're going to get, let's call it 10.62. Which means, on average, we're about 10.62 away from the mean, from $33. Some of our values were 8 away, one was 3 away, one was 5 away, one was 17 away, and sort of you can think of it as being about 10.62 away. Now, if this is your summer lawn business, I don't think that you care what the standard deviation is, but this number, this standard deviation, is going to have lots of implications for us later. All right, so that is standard deviation by hand. Let me pause for a second and enter these numbers in my calculator, and I'll show you on there. Okay, so I'm back from the calculator, and this is why we check stuff from time to time. What you do to find standard deviation, as was kind of shown in the last video, type your numbers into list 1, go stat, calc, enter, and SX 10.368, that's my standard deviation. Okay, S is the one we want right now. And I noticed that was slightly different, and you probably saw this mistake before I did, but my mistake happened over here. All right, 35 minus 33 is not 5, it's 2, which makes this 4, which makes this a little bit smaller, which makes this a little bit smaller, which makes this a little bit smaller. So I'm not going to go back and change all that on this video, but you should change that in your notes and don't be lousy at multiplying and subtracting like I am. So anyway, there's standard deviation. Right now, just worry about how to find it. We will apply it later on. Okay. Next thing, linear transformations. This basically is saying, what if we were to take our 5 numbers? All right, last summer you mowed for these prices, and gas is expensive, and you're a more skilled mower these days, so what if we raise the price on our customers? Right now, the mean is 33, and the standard deviation is, let me get the accurate one, is, let's call it 10.37, since we're in dollars and cents. What's going to happen to the mean and the standard deviation, to our measure of center and spread, if we adjust the prices? Okay, so there are a couple ways you can adjust the prices. You could, for instance, give everybody a $5 increase. Okay, now with 5 numbers, it wouldn't be too bad to just plug, you know, add 5 to them all and then start over, find a new mean and a standard deviation. But if you're talking about thousands of numbers, you don't want to go through and actually add to each one and recalculate your 2 numbers. You just want to know what's going to happen to the mean and standard deviation. If you average $33 per yard, let's get some titles here. This is linear transformations. What if we add to each number? Well, what's going to happen basically is the average is going to add that same thing. All right, the mean, you're going to add the same number. And that just kind of makes sense, I think. If you're getting 33 and everybody goes up 5, then your new mean is going to be $38. All right, you're going to get 25 new dollars a week, but spread out over 5 yards, that's going to be an extra 5 per. Standard deviation, what do you think is going to happen to that? All right, you can pause and think about it for a minute if you want, or I can just tell you. The standard deviation is not going to change. Okay, we are not changing how spread out my prices are relative to each other. We're just changing where they are on the number line, basically. Okay, year 1, I had a spread that was kind of like this. All right, I was getting 25 for a couple yards, I was getting a 30, I was getting a 35, and I was getting a 50. If everybody goes up $5, then all I've really done is I've taken this and made it a 30, and I've adjusted my scale, but the dots relative to each other have not changed their shape. They are no more spread out or less spread out than they were. All right? This is when you add to each number. What about if you multiply each number? What if instead of saying to your clients, I'm going to add $5, what if instead you say to them, I'm going to add 10%? Multiply each number. All right, so in this case, we'd be multiplying by 1.1 to get your new price, because that's a 10% increase. They're paying 110% of what they paid the year before. Okay, so what if we multiply? Well, my first price is going to be, see, I'm going to add 10%. So 10% of 25 is $250, so I'm going to be charging them $27.50. And I'm going to be charging the next 33. $35, I'm going to add $350 and be $38.50. And then this one's going to go up to 55 with a 10% increase. So if you multiply each number for the mean, I just noticed I didn't add that standard deviation, no change. Add to each number all day long, standard deviation won't change. So add that back in for part one. The mean, you're going to multiply by the same number. So my $33 average that I had year one is going to go up by 10%. So I'm going to add $3.30 and get $36.30. All right, that's just 33 times 1.1. Standard deviation, you can kind of see already up here that this multiplication didn't affect everybody the same way. All right, Mr. Big Yard at $50, he has a $5 increase. All right, small yards only had a $250 increase. They were paying half as much to start, so their increase is only going to be half as much. All right, it's kind of like a curve. Is your teacher going to curve your test by adding 10 to everybody, or by giving you half of your points back? You know, if they give you half of your points back, the people who missed a lot are going to get more because they had more lost in the first place. So for standard deviation, we are going to multiply by the same number. All right, so our standard deviation was 10.37. And if I take that and I multiply it by 1.1, the standard deviation is going to change, 11.407. Again, not a really important real-world value there, but it does change. Adding to each number, standard deviation won't change, and multiplying each number, it will change. In this case, it's kind of like sometimes you hear the rich get richer. If you have more money and you earn a certain percentage, then you're earning more than people who had less to invest in the first place. All right, so there is the rest, as far as the video goes, the rest of section 1-2, standard deviation by hand and by calculator, and then linear transformations. All right, so that's it for 1-2. Young out.